Today we're going to go over how to write the equation for a parabola in standard form. So I just want you to remember from yesterday that P measures the distance from the vertex to the focus, as well as the distance from the vertex to the directrix. So actually, if you look at your graph here, the vertex is the midpoint between the directrix and the focus, and this one isn't. It's easy to see it as it is here. This looks more like the midpoint, and it is, because P is equal distance on either side of the focus, or sorry, either side of the vertex, so you can find the focus or the directrix that way. Okay, I'd like you to circle all the places that you see P in the table below. The reason why I want you to do that is to understand how many times you use P when you're working with a parabola. Okay, in order to write the equation for a parabola, I recommend that you make a quick sketch of the given information to determine the direction of the opening. That's going to be real important, of the parabola. It's going to open one of four ways. Now, earlier in the year, we worked with parabolas that opened up or opened down. And just remember, your focus is going to be right in the middle, or the parabola is going to wrap around the focus. And the directrix is going to be on the other side of the vertex. Now, the directrix will never touch the parabola. If yours does, you did something wrong. The axis of symmetry is going to go through the focus and the vertex. So this is A. So the directrix is going to be here on the one that opens down. I'll just put a D there. And it's going, axis of symmetry is going to be here. Then we have parabolas that open left and right, and we did not go over those earlier in the year. So if it opens to the right, we're going to put the focus right here, and the directrix is going to be over here. Again, it never touches the parabola. The axis of symmetry is like the fold line. I'm going to put a D here and an A here to indicate that's the axis of symmetry, that's the directrix. And then we could also have a parabola that opens to the left. That would be if we have a negative value for P. So here's your focus. Again, your directrix is here on the other side of the vertex, which would be here. So this is the D. Axis of symmetry is going through the focus and the vertex. So this is A, and those are, you need to make sure you graph each one of those things. I'm going to put the vertex here, and put a V there. Okay, so when you go to write the equation for a parabola, you need to identify P. The reason why you need to identify P is because you see it in so many different places over here. And you also need to identify the vertex. Those are the two things that you need to write the equation for the parabola. And you also need to identify the opening. So here we're given a graph and we want to write the equation. So we need to first figure out if it's vertical or horizontal. If it wraps around the y-axis, it's going to be vertical. Okay, and then we need to figure out it is opening down, and the reason why we want to look at that is to decide if P is negative or positive. So you're actually using the absolute value of P to measure the distance, but if we kind of think about it, since it's opening down, in order to find the focus, we have to go down, and we have to go down 2, 4, 5, or I can count it this way, 2, 4, 5. So P, the absolute value of P, is 5, but we'll just put negative 5 here, and then the absolute value of negative 5 that will tell us the direction to go from the vertex. So our vertex is right here. We know our vertex is 0, 0. And we also know that P is 5. Okay, now look up here when you're writing the equation. You put 1 over 4P. 4P is in the denominator in both vertical and horizontal. So we're going to come back over here and we're going to write our equation. It's vertical, and we're going to say that it is y minus 0 equals 1 over 4p. So 1 over 4, and since it's opening down, it's going to be a negative 5, and then x minus 0 squared. Okay, if we simplify that, it's just going to be y equals 1 over negative 20 x squared. And that's all you need to do to write the equation for that parabola. All right, now let's go to the next one, and here you just have the vertex and the directrix. You might be given the vertex and the directrix, the vertex and the focus, so you could be given different pieces of information and asked to write the equation. So I'm just going to do a quick sketch. Vertex is going to be at 0, 0, and the directrix is at x equals -6. So 1, 2, 3, 4, 5, 6. This is your directrix. Okay, now you can find P, it's the distance from the vertex to the directrix, or from the vertex to the focus. So basically, since we went -6 this way, we know that P equals 6. All right, so I know my vertex is 0, 0, P equals 6, and I also know that my parabola goes through the vertex but never touches the directrix. So I know it's going to open this way. All right, so we can start out. We know the center is at 0, 0, so it's going to be x minus 0 equals, and it's 1 over 4p. And the parabola is pointing in the positive direction, so p is going to be positive. So we're going to do 1 over 4 times 6, and then we're going to say y minus, again, vertex is 0, 0, so it's going to be 0 squared. So we can simplify that by saying x equals 1 over 24 y squared. Now, when you look at this value that's in front of the squared term, if it's positive, the parabola should be pointing in the positive direction. This one's negative, so this parabola is pointing in the negative direction. So make sure you pay attention to what the sign of this value is, 1 over 4p. Okay, you have 2 questions to try on your own.